A very good morning to all the students. Today we are going to learn a new concept, a very important concept in Java, that is called as inheritance. Okay. Now, in your normal English, the meaning of inheritance is what? For example, we say many times we have inherited certain features or certain traits from our parents or from our grandparents, right? So, inheritance is basically a concept of reusability. Now, people must be telling you that C++ or Java, even Python, they are very powerful languages. You know what is the reason behind this? They are powerful because they have lot of inbuilt methods or inbuilt collections which are present, which the developers of C++ or Java or Python, they have written, so that you as a programmer, you don't have to write the full code from scratch. You can use some ready-made code which they have written for you, right? So, in C++, we have something called as standard template library, STL. Basically, these are nothing but some classes which they have written, some classes, some methods which they have written, inbuilt they are. So, suppose you are writing one program, you are creating your own class. Okay, C++ allows you to inherit those inbuilt classes, okay, so that you don't have to work from scratch. You can just focus on your code, and the inbuilt functionality will help you to reduce the lines of code that you make. So, this is reusability in C++. Now, in Java, we have a lot of collections. Okay, we have a lot of collections. You must have heard about the string class, right, which is the inbuilt class, or for that matter, you must have heard about vector class, you must have heard about string buffer class, or there is also a class called as math class. All these are inbuilt classes which are given for you, which are available for you, which are written by the developers of Java. Okay. So, now if you want to calculate something like power x raised to y, okay, you don't have to write the code from scratch. You can just use math class, and within math class you have an inbuilt method called as POW. So, you can just call that method, pass your parameters, and a raised to b or x raised to y can be directly calculated. So, this is basically possible because of the concept of inheritance. Similarly, in Python, there are lots and lots of inbuilt libraries in Python. Okay. So, these inbuilt libraries or inbuilt collections or inbuilt classes which are there, okay, these concepts, they make any programming language powerful. Okay. So, all this, the basis of all this, STL, collections, libraries, the basis of all this is basically inheritance, a concept called as inheritance. So, as I have already discussed, inheritance is basically used for reusability. Now, what is the definition of inheritance? Inheritance is the property by which, okay, a new class, okay, or a child class inherits or acquires, okay, all the properties of an already existing class. So, in simple words, we say inheritance is basically a concept wherein a child class inherits all the properties of an already existing class. Now, this already existing class which is ready for inheritance, it is also called as base class, or it is also called as parent class in the languages like C++. Whereas, in Java, this already existing class which is available for inheritance is called as super class. So, in Java it is called as super class, whereas the new class that you are building which will inherit the existing class or the base class, this new class is called as derived class, or it is called as child class. But in Java, it is called as subclass. So, using this keywords called as superclass and subclass, I can simply say what is inheritance in Java? Inheritance is the property by which a subclass inherits all the traits of its superclass. So, this is basically a definition of what is inheritance in Java. Okay. Now, let us quickly see what are the different types of inheritances. So, in Java as well as in C++, you have something called as single level inheritance, you have something called as multi-level inheritance, you have something called as hierarchical inheritance, you have something called as multiple inheritance, and finally you have something called as hybrid inheritance, which is basically combination of different inheritances. Okay. So, as time comes, we are going to see each of these different types of inheritances. So, let us quickly see the most basic type of inheritance, which is called as single level inheritance. Okay. Now, look at this figure. Assume that A is an already existing class and B is the class that you are creating now. So, inheritance is called as single level inheritance if the new class B which you are creating, if it inherits all the properties of a single parent class A, right. So, then we say that B inherits A. B, that is the new class that you are creating, inherits A which is already existing class. Okay. Now, in Java, for this word called as inherits, there is a keyword which is called as extends. So, in Java, there is a keyword called as extends. So, when I write B extends A, it simply means that B is a subclass which inherits A which is an already existing superclass. Now, how do we implement this single level inheritance in Java? So, let us quickly see a simple program. I will assume that I have a class called as a student class. Okay. And let us say this student class is already existing class. It has attributes, say name of the student, okay, and say age of the student, and let us say it has a roll number of the student. Let us say 3 attributes, and it has 2 functions. One is the constructor, its own constructor with some parameters, and there is another method that is called as print info. So, let us say this is an already existing class called as student, which has 3 fields, that is name, age and roll number, and 2 methods, out of which one is a constructor and second is a print info method. Now, let us say I create a new class called as result. Okay. Now, let us say I want to calculate the result of a student. Now, this result class, okay, it has its own attributes. One is the aggregate marks of the student, and let us say percentage of the student. These are 2 fields, and the methods are, one is the constructor, and second there is something called as display method, say, which will basically display the result of the student, right. Now, notice that my result class, okay, which I am going to construct now, this result class will handle the calculation of the result, but then whose result? It is some student's result. Now, that student is a separate class, already existing class. So, what I will do is, I will inherit, my result class will inherit the student class. So, what I want to say is, I want to say that result class, I want to say that class result extends student. And when this happens, what will happen is, once result class inherits all the properties of the student, name, age, roll number, these will be the part and parcel variables of the result class, as if result class was having 3 more variables called as name, age and roll number. Similarly, the object of the result class will be able to access the student, the print info method of the student class as if it was its own method. Like how the object of the result class would have accessed display function or display method, in the same manner, the object of the result class would be also able to access the print info method, right. So now, this is a simple program that I want to construct. So let me start. I will first create a class called as student, fine. And as I have told you, student will have following attributes. You have string name, you have say float age, okay, and let us say int roll number. So, these are the 3 attributes or 3 fields of the student class. Apart from this, there is a constructor of the student class. Okay, S is capital here. The constructor of the student class, what it will do? It will basically take input from the public static void main, and those input values are to be fed into name, age and roll number attributes. Okay, so say string n, float a and int r. Okay, so basically n, a and r, okay, these are the values that will be passed from the public static void main while creating object, and those values will be stored in name. So that code I am writing now. So name equal to n, okay, age equal to a and roll number equal to r. So this is a simple constructor of the student class. Now once the name, age and roll number is taken from the main while creating the object, it is going to assign name, age and roll number attributes of that particular object of class student with those values. And then there is also, as I have told you, there is also another method called as print info that will simply print the information of the student. So I will say void print info. This method is going to simply print the values. So I say system dot out dot println it will simply print name of the student is plus name, then age of the student will be age, and finally roll number of the student will be R. So this is the end of the student class. So the object of the student class, if you are creating that object of the student class, okay, when you are going to initialize the object of the student class, automatically constructor is called. We have already seen whenever the object is created, the constructor of that class is automatically called, and while creating the object, whatever parameters that you pass, those will be stored in n, a and r, and then from n, a, r variables they will be moved into name, age and roll number attributes of the student classes object. But remember students, whenever we are talking about inheritance, okay, your class that you are going to create is a result class. So for your computation, you will be using object of the result class and not the object of the student class. So you as an end user, since you are creating a result class and since student class is already existing, you will be interacting with the program with the object of the result class and not with the object of the student class. Okay. So, now let us quickly define this result class. So, I create another class, I say class result, and then I say class result extends, that is inherits, okay, student class. So, when I write this keyword called as extend, it tells the interpreter that all these attributes now are part and parcel of the result class as well. So, object of the result class can now easily access name, roll number and age of the student, and he can easily access the print info function at any point of time to print the name, age and roll number as if it is its own function. Okay. Now, result class also has two more attributes, one is aggregate, second one is percentage. So, let us quickly declare that. So, let us say float aggregate, and you can say percentage, let us say float percentage. Okay. Now, let us create the constructor of the result class. Now, before I create the constructor of the result class, okay, let us say this is the starting bracket of the result class and I am not writing the code here. Let us say this is the closing bracket of the result class. Okay. Now, and see the code which is there here, we will be writing after some time. Let me first write the main class where public static void main function will be called. Let me first write that. Okay. So, I say I create another class called as inheritance demo, okay. So, this is my class and in this I have your main function, say public static void main string args. Okay. Now, since my result class is the class that I am creating, I will be creating object of the result class. So, let me create object of the result class. So, I say result, say R1 equal to new result, and here when I create object, as you know, when object is created, constructor is automatically called. While creating object, I will be passing some values to this constructor. For example, I will be passing the name of the student, say Ajay, fine. So, that name is basically the first parameter that is inherited. Then age, let us say age is 18.5 and roll number, which is integer value, let us say the roll number of the student is let us say 5. So, notice that the first three parameters are the parameters of name, age and roll number variables which are actually inherited by the result class now. Whereas, the remaining two parameters which I am going to write will be the personal parameters of the result class, that is aggregate and percentage. So, next I will be passing percentage and aggregate. Let us say aggregate is say 655 and percentage it says 70%, example, right. So, how I create object of the derived class or the subclass. So, R1 is the name of the object of the subclass called as result, and while creating the object I am also passing the attributes. Out of these attributes, as I have already told you, the first three attributes are inherited from the student class, whereas the remaining two attributes are the personal attributes of the result class. Now, as you know, when the object is created, the constructor is automatically called. So, this is basically a call to the constructor and these are the actual parameters which are passed. So, when there is a call to the constructor, the control will pass here to this constructor called as result. So, let me write the definition of the result constructor. So, now when the call, this is a call to the constructor. When the call gets linked to the code, the actual parameters are copied into the formal parameters. So I require formal parameters here. So Ajay, to store Ajay, I require the string variable. So I will just say string n, which represents the name. Then to store 18.5, which is basically age of the student, I require a floating point variable a. Then a roll number integer variable, say r. Then aggregate, it's a floating point variable, say agg. And again percentage is a floating point variable, percentage per. Okay. Now, so when object of the derived class or when the object of the subclass, your class is created, basically all the parameters are passed, right? Out of this, the first 3 parameters are the parameters for the student class and remaining 2 are the parameters for the result class. Now this call gets linked to the code and n gets the value Ajay, a gets the value 18.5, r gets the value 5, aggregate gets the value 655, per gets the value 70. But students note, the first 3 parameters, as I told you, n, a and r, right now they have got some values, but don't you think these values have to be passed further to the constructor of the student class, so that the constructor of the student class can take those values and assign name, age and roll number with those values, right? So in Java, there is a subclass constructor that we are going to write. So there is a keyword here called as super, and I will write n comma a comma r. So this is basically called as subclass constructor. Now by writing this line here, it tells the interpreter that out of all the different values which are passed from the main function, okay, NAR, that is the first 3 values, please pass them to the super class of this particular class. So this code here, it tells, super is a keyword, this code tells that out of all the parameters which are supplied while declaring object here, the first 3 parameters NAR, basically they are the parameters of the student class. So NAR, please pass them to the super class. So when this line is written, the control will automatically pass from here to the constructor of the super class. Okay, from here the control passes directly to the constructor of the super class here, right? Now at this moment, n already has the value called as Ajay, a already has the value called as 18.5, r already has the value called as 5. So this is basically a call to a super class constructor. So when the call gets linked to the definition of the super class constructor, what happens? This n, which contains Ajay, is copied in this n. Notice that this n and this n, they are different variables, although different names, but they are at different, they are not in the same folder, right? They are different, at different regions they are, right? So this n, that is Ajay, gets copied in n, then a, which is nothing but it is 18.5, this a 18.5 gets copied in this a. So here n is Ajay, a is 18.5, and r, that is this r, is basically nothing but it is 5, right? 5 that is stored in this r. Okay, so r which is copied here is also 5. So when this particular line is written, it is basically a call to a super class constructor. Okay, so super class constructor is called and the value are passed. So n is Ajay, a is 18.5, r is 5, and then the definition of the constructor assigns that n to name. So Ajay will be the name, 18.5 will be the age, and 5 will be the roll number, correct? So what will happen is, now see, okay, now see, when the object is created in the memory, the object called as R1, it will have name attribute, it will have age attribute, and it will have name age, and it will have roll number attribute. Okay. Now, these three attributes are actually from the student class, but since there is inheritance, R1 object will have name, age and roll number as if they are its own copies. Plus, it will also have your aggregate variable, and it will also have percentage variable. Right. So, now what has happened is, after these values are passed, okay, there is a call to the constructor of the subclass. Now, constructor of the subclass in turn passes the first three values to the superclass, and now that these values are stored in name, age, roll number, the question is name, age, roll number of which object? The object which is actually calling the subclass constructor. So, name of R1 will be set as Ajay, age of R1 will be 18.5, and roll number will be set to 5. Okay. So, this is a small code that I have written here, and now I have to also assign aggregate and percentage the values of AGG and PR which are supplied from the main. So, apart from this, I will be now writing a normal code, and I will be writing the aggregate, which is nothing but this variable's value is nothing but AGG, that is supplied from the main, and the percentage attribute will have PER, that is supplied from the main. So, this is how the constructor of this particular class, that is a result class, that will be written. And now, as I told you, there is also another function or another method called as display, and display method will simply display the aggregate and percentage of the student. So, again I will be writing a display function. So, I will say void display, and this display method will simply print system dot out dot println. It will say aggregate, it will print aggregate, which is nothing but aggregate variables value. Then we will go to the new line, okay, and then we will print percentage, and percentage will have percentage variables value. Okay. So, this is simple display function. This is the end of the class called as result. So, this is your result class, right, and this is your student class. Yes. So, now what will happen is, see, R1 equal to new result. So, the first three parameters here, super will pass them to the superclass constructor, name, age, roll number will be assigned those values as we have already seen. Then the next line here, AGG will be set in aggregate. Okay. So, aggregate will be set to 655, and percentage will be set to 70. So, when the object is created and these values are passed, this is how the object gets different values. So, remember this particular line, this is called as subclass constructor. So, in the definition of the child classes constructor, there is a code, that is a small code that you are going to write, that is going to pass the parameters to the superclass. So, this is called as subclass constructor, and then you can assign the values of subclass. And now it is very simple. R1 is then going to call the function. Basically, you are going to print now. So, R1 is going to call print info function of the student class. Since R1 is inheriting student class, it will treat print info as its own function. So, R1 can just use dot operator and call print info function as if it is its own function. and then R1 is also going to call this print info function is going to print basically what? The name, age and roll number. So, it is going to print name as Ajay, age is 18.5, roll number is 5, and then there is also another function that we have written in result class, that is called a display function, which is going to print aggregate and percentage. So, R1 can also call display function, which is its own function, and this is basically the public static void main. So, this is how objects values will be printed. So, this is how single level inheritance program can be written. So, this is the program, this is that student class which I had mentioned, name, branch, roll number and age are the parameters. This is the constructor of the student class, right. Now, in main you can see a result class object is created R1, and we are passing the name, the branch, the roll number of the student, the age, the aggregate and percentage, all parameters. Now, when object is created, automatically the constructor of that object is called. So, result class's constructor will be called and these parameters will be copied in its formal parameters. Which is the result class constructor? This constructor. And all these values will be copied into all these variables. Now, out of these values, we are saying that n, b and r are supposed to be the parameters of, n, b, r and a. First 4 parameters are supposed to be the parameters of the student class, right. So, we will be calling this, we will be writing this super, that is a subclass constructor, which basically does what? It passes the first 4, 1, 2, 3, 4, which passes the first 4 parameters to the constructor of the super class. So, there is a call made to the constructor of the super class by reading this particular line, and the super class constructor is this. So, n, b, r, a, those values which are nothing but Rajesh, etc., the roll number value and 21, they will be now copied in n, b, r, roll and a. Okay. So, these are the actual parameters in the call and these are the formal parameters. When the call gets linked to the code, the actual parameters are copied into the formal parameters, as we know. Okay. And then this n is stored in, n will be stored in name variable, which is a member of the object, br will be stored in branch, roll number will be stored in roll number, a will be stored in age. Now, name, branch, roll number, age, these are attributes of which object? The object which has ultimately called all this, it is R1. Object R1 has been instantiated with these values. So, the name attribute of R1 will be set to Rajesh, branch attribute of R1 will be set to the value etc. and so on. So, from here the call gets goes to the constructor of the super class. Once the super class constructor execution is over, the control passes back to the line, to the next line after this super. So, control passes here. Okay. After the super class constructor is called, after the super class constructor assignment is over, when this closing bracket is encountered, the control is going to come back to the place from where it was called. It was called from here. So, the control is going to come to the next line here. Then the aggregate variable will be set to AGG, which is passed from the main. So, okay, and similarly percentage variable of that R1 object will be set to P, which is again passed from the main. So, this is the end of your constructor of the derived class, right. So, this one line is going to create the object called as R1 and all these values will be set in its fields. Then object R1 is going to call student info, which is basically a method of the base class, but since it is inheriting it, it will be calling this method as if its own method using dot operator. Student info is going to simply print name, branch, roll number, age of R1, and then display result will simply print aggregate and percentage of R1. So, I am running this code and you will see that name happens to be Rajesh, branch is etc., roll number is this, age, aggregate and percentage has been set to the object of the class result, that is R1. Okay. The next concept is multi-level inheritance. Okay, we have seen single level inheritance. The next concept is multi-level inheritance. But before going to this multi-level inheritance, okay, in single level inheritance itself, there are some more things that we are yet to discuss. Okay. Now, let's see this same program of single inheritance. Okay, but what we will do is we will simply change the name of the methods. For example, in the previous lecture, we have already spoken about something called as method overloading, where in the same class you can have methods with the same name and the same return type. Okay, but maybe the parameters are different and so on. So that means in one class you can have the methods with the same name. Either the return type should be different, or the number of parameters should be different, or the data types of those parameters should be different. But you can have methods with the same name. So that is called as method overloading. Now what we will do is we will slightly modify this program so that it will look like this. I will just show you. Now look at this particular code. You have the same class called as student, same attributes, this is the same constructor, and this student class finally displays the student information, that is name, branch, roll number and age. Everything is same. Again I have created a result class which extends student. Result class has its own attributes called as percentage and aggregate, and this is the constructor. It is same constructor of the result class. But the difference is I have changed the name of the method of the result class. Earlier it was display method. Right now what I have done, I have made it sure that both these methods, the method from the student class and the method from this result class, their names are same. So here also it is void student info, and here also it is void student info. So what happens is, now when the object R of the derived class or the subclass is created, okay, since subclass, that is result class, it inherits all the traits of the student class, don't you think it is going to get two copies of the methods? The method will have the same name, student info, in the parent class as well as in the derived class, in both the classes. In the derived class as well as in the parent class, you will have the same method. Now the question is, if the object R, which is of the derived class or the subclass, if this R calls student info method, then which method will be called? Whether the method from the subclass will be called or the method from the superclass will be called. Notice that R is the object of the result class. What is result class? Result class has inherited all the traits from the student class. So it must also have inherited the method called as student info. So what is happening right now is, this R can access the student info method of its own class as well as of the parent class. But notice that when R tries to call student info method, you will see that it overrides the method of the superclass. This R happens to be the object of which class? It is the object of student class or it is the object of the result class. So R is basically the object of the result class. As a result, when it is going to call student info function, notice that student info function is present in the result class as well as in the student class. But since R is the object of the result class, it is going to override the method called as student info from the superclass, and it is not going to call this method, but it is going to call this method, its own method. And this is called as method overriding. So which function to be called? Whether the function from the base class or whether the function from the derived class. Which function is to be called? This is decided based on who is calling that particular function. When I say who, object of which class is calling that function. Now since R is the object of result class, it will call the student info function of its own class rather than the student info function of the base class which it is extending. So if you run this code, you will notice that aggregate, that is 46, and percentage, that is 75 only, right? Which means that R, although object R, all the values are set in object R, but when it is trying to call the student info function, there is the same name function student info in the base class as well as in the derived class. But since R is the object of the derived class, when it calls the student info function, it will call the student info function of its own class rather than calling the student info function of the base class or the parent class. This is called as method overriding. What is method overriding? When you have a base class, or let us say when you have a super class, let us say super, okay, and in this super class suppose you have a method 1, okay, and then you have a subclass again which extends superclass. Again notice that this subclass, it also has the same method with the same name, say method 1. Okay. Now see, superclass and subclass, both of them they have the same method name, void method 1, this also has void method 1. But when I am going to create object of the subclass, let us say I create an object of the subclass, I say sub obj is the object equal to new sub, okay, and then when this object obj is going to call method 1 function, what will happen is, since obj is the object of the subclass, its data type is subclass, okay, although it can access the method from the base as well as the method from the derived class, but when it calls method 1 from the subclass will be called and method 1 from the superclass will be overridden. This is called as overriding. Why? Because obj's data type is of type sub. So when obj calls method 1, it will call the method of its own class rather than calling the method of its superclass. So this is called as method overloading, method overriding. Which means, okay, method overriding in simple word, it means overriding or not calling the function from the base class or function from the superclass, rather calling the same function name from the subclass. Avoiding accessing the method from the superclass is called as method overriding. Okay. So this is basically called as method overriding. Now in many cases for us it is required, okay, that we want to every time call the function from the superclass and not from the subclass. Suppose when I say r.studentinfo, suppose if I want studentinfo function from the superclass to be called, from this class to be called rather than the subclass, then what I will do? Okay. So then you have a keyword called as final that we can use. Okay. Now see, in Java there is a keyword called as final which is used, and there are three uses of this final keyword. One, final keyword can be used if you don't want to override the method from the base class. Just in the previous example we saw that when the object of the derived class is created, when it tries to call the method from the base class will be overridden, and which method will be called? The method from the derived class will be called. Suppose you don't want that to happen. If you don't want to override the method from the base class, which means the derived class object, when it calls the method, you want the method of the base class only to be called, not from the derived class, then you can use a keyword called as final. One. Second usage of this final keyword is when you don't want a class to be inherited any further. Many times it is required that you create a class, and suppose if you don't want this class to be inherited by anybody anytime, then you can declare that class with the keyword called as final. We are going to see that now. Okay. And third use of final keyword is when you want to declare a constant. So final keyword can be used in 3 places. We will see one by one. So first, let us see this overriding issue. So as I have told you, final keyword can be used if you don't want to override the method from the base class. So let us see that. Okay. Now in this particular simple program, I have created a class called as superclass. This superclass has a simple method called as print message. Okay, void print message is the method in the superclass. It simply prints I am print message method from the superclass. It says that I am a print message method from the superclass. Okay, so this is one class, superclass. Then I have also created a subclass which extends superclass. So subclass is a derived class or subclass of the superclass. Okay, and in the subclass again I have created the similar or the method with the same name, same return type, void print message. So you see here also there is void print message, here also there is void print message, but here it prints another thing. What it prints? It prints that I am print message method from the subclass. Here it prints I am print message method from the superclass. Here it prints I am print message method from the subclass. Fine. Now let us see what happens. So let's say this is my public class finalized demo which has public static void main. So in void main, the very first thing what I do is I create object of the subclass. Let's say sub is the object of the subclass. So I have created object of my subclass, sub. Okay. This is the first thing. Now, when the object of the subclass is created, as you know that since subclass inherits the superclass, all the properties, all the methods, all the properties of the superclass will be also inherited in the subclass. So object will be able to, this sub object will be able to access this print message method as well as this print message method. Now the point is, when it tries to access print message method, which method will be called? As it is, we have seen in the previous program that if suppose sub object calls print message method, okay, suppose it calls print message method, if you happen to run this code, you will realize that it is calling what? I am print message method from the subclass. So although the object called as sub, okay, it can access superclass method as well as subclass method, but when it calls the print message method, it overrides the superclasses method and it has just now accessed this method, and that's why you have seen the message I am print message method from the subclass printed on the computer screen, as you can see here. Okay, so what has happened is it has overridden the superclass method. Now, if you don't want to override the method from the base class, then what you do is you just see in this method of the superclass, I just declared a keyword called as final. So that is what I write here. See, try calling print message method. Okay, we have just seen what it prints. Yes. Now, what we are trying to do now? Now, use the final keyword for print message method from the base class and see what happens. So, this is the print message method from the base class. I will just use a final keyword for it. And when I use a final keyword for this, final keyword tells that in any circumstance, print message method of the superclass will be always called. So when you use final method here, it will not allow you to create any method with the same name in any of the subclasses. See when I declare final here, see what error has been created here in the subclasses print message method. If I just hover the mouse, it says in subclass print method message in subclass cannot override print message method in the superclass. Why? Because overwritten method is final. It shows error over here. As such, if you try to run this program, it will say that it has got the compile errors. If you still run anyway, it will show you that there is an exception which is created. Why? Because you have just used final method called as print message. So whenever you have final keyword attached to the method in the super class, it will not allow you to create another method with the same name in the subclass. Understood? So when you use final keyword with a method in the super class, it will not allow you to create another method with the same name in any of the subclass. It will create an exception. So this way method overriding problem can be solved. So every time, no matter which subclass object is going to call this print message function, every time only the superclass's print message method will be called. Why? Because when you use final keyword, it does not allow any subclass, okay, to use to declare the same method with the same name and same return type. It does not allow. So this is one use of the final keyword, right? Now let us see what is the second use of the final keyword. Final keyword can be used when we don't want a class to be inherited any further. Many a times we write a class, and suppose we don't want in future anybody should be able to inherit whatever I have written. I want to make my code unique, and I am reluctant in giving this code to anybody who is going to do work in future. So if I don't want my class to be inherited by anybody in future, you just declare that class with a keyword called as final. So what I will do, this super class, I will just say, I will use a word called as final with this super class. And now see what happens. So when I use a keyword called as final with the super class, there is an error that comes here in the subclass declaration. And what that error is, you just hover the mouse here, it says cannot inherit from final super class. It is telling you that since the super class has been declared as final, subclass cannot inherit anything from such class. Okay, so this is the second use of final keyword. So when final keyword is attached to any of the class, it simply means that that class, it cannot be inherited by anybody in the near future. So this is the second use of the final keyword. Okay, and now the third use of the final keyword. Basically this final keyword is used to declare constants. Okay, now let's just to show you an example. Okay, now this third use of final keyword has got nothing to do with inheritance, but let's say I declare an integer variable called as int I equal to 10. Okay, just see, I declare a variable called as int I equal to 10. Variable I stores the value 10. Then I say I equal to I plus 1, and I simply try to print system.print.println. I try to print I equal to, I try to print the value of I. Okay, so what will happen? I is 10, then you incremented I by 1, so I becomes 11. So what I should contain now? 11. Let's save and let's run this program and see. So as you can see, I is set as 11. Now, what happens when a final keyword is used along with a variable? So if I say final int I equal to 10, this final keyword, when it is used with the variable declaration, it tells the interpreter that I, okay, this I is basically a constant, and as you know, constants cannot change. So what has happened? You have tried here to change the constant. You are trying here to set I to an incremented value. So you see there is an error that comes here. Just over your mouse here, it says it cannot assign a value to a final variable I. Okay. Now if you had not done this, then it would have printed the value of I. That is no problem. Say it would have printed I equal to 10. Right? It prints I equal to 10. But when you try to change the value of I, when I is declared as final, it is going to give you error saying that see, I is a constant and constant will remain same throughout the program. Constant cannot be changed, right? So this is the third use of final keyword. Fine. So notice that final keyword it has three uses. One, if you do not want to override the method from the base class, then just use a final keyword with the base classes method. It will be always called. And if you try to create another subclass with the same method, it will give you error, exception it will give you. Second use of final keyword is, if you have a class and if you want this class not to be inherited by anybody in future, just declare that class with final keyword. No other class in future will be able to inherit your class, right? And third use of final keyword is when you use this final keyword with a variable declaration, that variable is declared as a constant and it cannot change throughout the program. So this is basically something called as final method. Okay. We will go to our third concept, that is called as abstract keyword, abstract classes. Okay. Now, when do we use keyword called as abstract? In C++, see, we have come from C++, those who have come from C++, you will realize that in C++ there is a class called as abstract class. Then the meaning of the abstract class is what? Okay. Abstract class its only purpose is that it should be inherited in the future. Okay. The only aim of this abstract class is that it should be inherited by some other class in the future. An abstract class cannot have the objects of its own. Okay. So abstract class is basically a class which will never have objects of its own. And the whole purpose of this abstract class is what? Is that some other class should inherit it. That's the only purpose. Similarly, there is also something called as abstract method or abstract function. Abstract method or abstract function, they are called as placeholders, where the definition of the method is not written. So whichever class who is going to inherit this particular class, it will define the definition of that method. Let us see this with a program. Okay. So that it will be more clear to you. Now, I have declared a class called as 2D shape. Ignore this keyword called as abstract right now. I have declared a class called as 2D shape. Now, this 2D shape class, it has two parameters, dim1 and dim2. Dim1 and dim2 are basically dimensions of 2D shape. Then you notice that I have a method called as getDimension and another method called as printArea, the two methods that I have created in this particular class called as 2D shape. Notice that after declaring the method, I am just putting a semicolon here and there is no definition of the method written here. Method definitions are not written, only the method names are written or method prototype is written. Okay. So, whenever see, many a times what you want is, in the base class, you want only the method declarations and you want that the definitions of this method be written by only the subclasses. Okay. So, by writing keyword called as abstract, you are telling the interpreter that, okay, getDimensions and printArea, these are just the placeholder functions. You are telling the interpreter that later on, whichever class is going to inherit me, that means whichever class is going to inherit this 2D shape, that class will have to define a function called as getDimensions, which will be of type void, and that subclass will write the code for the getDimensions. Similarly, abstract keyword tells the interpreter that whichever class is going to inherit the class called as 2D shape, that class will have to define a method called as printArea, whose return type will be void, and the code for that printArea will be written by that subclass. Okay. So, by writing abstract void getDimension, you are just telling the subclasses who are going to inherit this class that please see to it that you define functions called as getDimensions and printArea in your code and you write the definitions according to your own need. Remember, whichever class have these abstract methods that class should be also declared with a keyword called as abstract, and that's why I have written here abstract class. So the purpose of the abstract class called as 2D shape is that the only purpose is that it should be inherited by somebody. Okay, 2D shape will never have objects of its own, rather the classes that inherit 2D shape will have their own objects. Okay, now let's see how I have made use of this concept. Now 2D shape is in general a two-dimensional shape, and any two-dimensional shape will have two dimension values, right? So by writing this abstract class, I am just saying that a 2D shape will have dimension 1, dimension 2, 2 dimensions, and I am also telling that I will have to write two methods, get dimension that will take the dimensions from the user, and print area that will take those dimensions and print the area of that particular 2D shape. So this is a generalized abstract method. Now there is a class called as rectangle, and this rectangle class inherits 2D shape. Now when rectangle class inherits 2D shape, it will inherit all the traits of the 2D shape. So dim1, dim2 will be inherited. Similarly, get dimensions, print area will be also inherited. Now rectangle, it now defines get dimensions according to its own need. So how it defines this get dimension? Notice that the name of the function should be same, and the return type also should be same, number of parameters also should be same. By writing abstract here, the superclass has told you that you please see that you are writing a function called as get dimension, which will have the same return type and which will have the same number of parameters. Only thing is that the function definition you write according to your need, but the blueprint which is there, you please keep it same. Okay, so rectangle, it defines get dimensions like this. It will just print a message, subclass get dimension method is called. Similarly, it will define print area function. It says subclasses print area method is called, right? So this is a rectangle class. Now this is your class abstract demo that contains public static void main. Okay, now the first thing what we will do is we will try creating objects of 2D shape. Okay, let's see what happens. So I try creating object 3D of 2D shape. I just told you abstract class cannot have object of its own. Its sole purpose is that somebody else should inherit it and create its own objects. But 2D class, 2D shape class, since it is abstract, it cannot create objects of its own. So when you try to create object of type 2D shape, you get an error here. It says 2D shape is abstract and it cannot be instantiated. That means object cannot be created of 2D shape class, since it's an abstract class. Now further, let us try creating objects of type rectangle. So let's say R is the object of type rectangle. Now let's say R calls get dimension functions. Okay, so R will call get dimension function, so it will be this function, and then R calls print area function, so it will be this print area function. When you run this program, first it calls get dimension function, so it says subclass get dimensions method is called, and then it calls print area function, so it calls it and says subclass print area method is called. So then, to recapitulate whatever I have told, remember sometimes it is required that the superclass should only have placeholder functions. Superclass should only define, suppose, the blueprints of what will be the function, what will be its return types, and what will be the parameters that are accepted. So you can define the blueprints of the methods using abstract keyword, right? So this abstract keyword tells the interpreter that get dimension and print area, they are abstract methods. That means they are just placeholder methods. We will not be defining them in the superclass. But whichever subclass that is going to inherit this particular 2D shape class, abstract class, that subclass will see to it that it defines get dimensions and print area according to its need, right? So this is basically the concept of abstract class and abstract methods.